All right, consider the reaction where two irons react with three chlorine molecules to give two iron 3-chloride formula units. Consider that you have 14 moles of iron 3-chloride. 14 moles of iron 3-chloride. How many moles of chlorine are required to form that? Consider that this reaction where we have these coefficients here tells us about the number of atoms, molecules, and formula units, but it also tells us about the number of moles of each thing. This 2 can mean that we have 2 moles of iron. This 3 can mean that we have 3 moles of chlorine, and this 2 can mean we have 2 moles of iron 3-chloride formed from those. This ratio of 2 to 3 to 2 is consistent no matter how many moles of these particles reactant are formed. For example, if you were to react twice as many moles of iron and chlorine, you would form twice as many moles of iron 3-chloride. There is a 3 to 2 ratio of moles of chlorine versus iron 3-chloride in this case, and in the next case, and in all cases. Considering this, if you wanted to form 14 moles of iron 3-chloride, how many moles of chlorine would you need? Well, you still need this 3 to 2 ratio of chlorine to iron 3-chloride, and so you need 3 over 2 times 14 moles of iron. Actually, chlorine. You need 3 over 2 times 14. You need 21 moles of chlorine. This is one way of thinking about the problem, but the much better way, the much more consistent way, is to deal with unit conversion factors in dimensional analysis. If we're told that we have 14 moles of iron 3-chloride formed, how many moles of chlorine were required? Convert from moles of iron 3-chloride into moles of chlorine using the mole-mole ratio. The mole-mole ratio. This is the ratio of these two compounds within the balanced chemical equation. The numbers that we use to convert between moles of one thing and another are the coefficients in the balanced chemical equation. For example, there is a 3 in front of chlorine in our balanced chemical equation. Hence, we need to put a 3 in front of moles of chlorine here. And there is a 2 in front of iron 3-chloride in this balanced chemical equation, and hence we'll be putting a 2 in front of moles of iron 3-chloride in this mole-mole ratio. You see, we are multiplying 14 by 3 over 2 to find 21 moles of chlorine are required. Now, this is a fairly simple problem, but you'll deal with much more complex problems, for example, where you have to go from grams of something into grams of some other compound. For example, in the question, how many grams of iron 3-chloride can be produced if 17.4 grams of chlorine react with an excess of the other reactant, iron? So you're given the grams of chlorine, and you want to find the grams of this different compound. How can you convert between one type of compound and a different compound? The only way to do this is by converting through them via the mole. We just saw how you could go from moles of one thing into moles of another using the mole-mole ratio. And so to use this mole-mole ratio to convert between these compounds, we must go into moles of chlorine, then moles of iron 3-chloride, and then finally grams of iron 3-chloride. Yes, in order to convert between some amount of one compound and some amount of a different compound, you must go to your happy place, the land of the mole. Almost every problem in this chapter requires that you put mole of one compound and then another in the middle of your conversions. This is your happy place where leprechauns will prance about and deer will eat out of the palm of your hand if you know to go into the land of the mole then you will, I guess, know the path that you need to follow almost all the time in this chapter. And so kind of working out this map using unit conversion factors, you see that we have 1, 2, 3 unit conversions, hence we need 1, 2, 3 unit conversion factors. We can go from grams to moles to grams. And so to get out of the unit of grams of chlorine, we have that on top, and then we have it on bottom. Grams of chlorine into moles of chlorine. And then to get out of moles of chlorine and into moles of iron-3 chloride, we have moles of chlorine on top and then on bottom. And then to go from moles of iron-3 chloride into grams of iron-3 chloride, we have moles of iron-3 chloride on top and on bottom. So our units all cancel out. We know then that we've properly worked this problem. We have grams of iron-3 chloride at the end, which is exactly what you were asked for, the mass of iron-3 chloride. And so you need to just fill in some numbers here. How many moles and grams? Well, to convert between mass and moles, moles and mass, you need molar mass, the mass of 1 mole of chlorine. So the molar mass of chlorine, Cl2, is 70.90 grams. And then to convert between moles of chlorine and moles of iron-3 chloride, using this mole-mole ratio, then you need to, again, use coefficients. Use coefficients from the balanced chemical equation in your mole-mole ratio. So, for example, in front of moles of iron-3 chloride, we'll put 2. That's the coefficient in front of iron-3 chloride. And in front of chlorine, we'll put 3, the coefficient in front of chlorine. So 2 in front of iron-3 chloride, 3 in front of chlorine. And then finally, to go from moles of iron-3 chloride into grams of iron-3 chloride, again, between mass and moles, we must use molar mass. It's 162.2 grams of iron-3 chloride per 1 mole of iron-3 chloride, leaving us 26.3 grams of iron-3 chloride. So you take all the top numbers, the numerators, multiply them, 17.4 times 2 times 162.2, and then divide by the numbers in the denominator. Remember that if there are 2 or more numbers in the denominator, then you need to use parentheses as you plug into your calculator, or just press enter more frequently. So I guess the general kind of format that we used in this problem was we had some given compound, some amount of some given compound, and we wanted to find some amount of the compound that we wanted. To go from the amount of given into the compound into the amount of the compound that we want, we need to follow this this model. For example, if you were to start with grams of your given compound and you wanted to go into grams of the compound that you want, then you would need to do just like up top. You would use the molar mass of the given compound and 1 mole of that given compound. So that puts you into moles of the given compound, but then you wanted to go into moles of the compound that you want. And so to go from moles of one compound into moles of another, you need to use the coefficients from the balanced chemical equation. And so you would use B as in front of W here, and A as in front of the given here. And then to go from moles of what we want into grams of what we want, again we use 1 mole is equal to the molar mass of what we want. And so we just saw that to go from grams of one compound into another, we had to follow all of these steps. What if you just wanted to go from moles of one compound into another? Well, then you would just start with the number of moles that you're given and then multiply by this unit conversion factor. What if you wanted to go from moles of a compound into grams of a different compound? Well, to go from here to here, you need to multiply by this unit conversion factor and then this unit conversion factor. You don't have to stop to find all of these things in the middle. Start wherever you need to, end where you need to, and just on the way multiply by all of the unit conversion factors, as we did up here, where to go from grams of one compound into another, we just multiplied by those 3 unit conversion factors. Thanks for watching, guys.